Okay. So again, our goals are trying to figure out what this function is. How is the velocity change with the radial coordinate in the pipe? So that is the thing. That's the function that we're after, and we're going to do it with a control volume. So we actually don't really know what this curve is, but that's where we're headed. We're going to figure out how is velocity distributed throughout the pipe. So we have this axis, and we're going to draw one of these control volumes. So this is my control volume that I'm going to pose. It's centered around the medial axis, and it has some normal vector oriented over all the surfaces. You can see that I'm just drawing perpendicular vectors, which represent normal vectors to the surface. Okay, so let's just run a Newton's second law on this and try to look at the forces that are happening. Really, this is a cylinder, by the way. So, here's the pressure, and then I also have on this side, here is pressure plus my change in pressure, and I've drawn it pointing inward because it's just like when you did statics. You just draw the arrows a certain way, and then the math will tell you if that algebraic sign is correct. Okay, what else do we have? And then you'll have these shear forces here. So maybe let's just say this could be a something like that, where again it's this from this point, this would be the shear on this surface with that expansion, shear on the top surface plus expansion. They don't end up really mattering, but so that's a force balance on this. That's a force balance on there. So I'm going to erase this. Hopefully you've drawn that. Okay. Now, what is Newton's law second say? So that says that the sum of the forces in the x direction should be equal to dp dt, where P represents linear momentum. Okay, so what's going to happen is we're going to attack this from both sides, sort of consider them independently, and then we will derive something. So first, let's just consider this dp dt, and we'll use the control volume things with integrals, and we'll derive a fundamental property of fully developed flow. Okay,